Okay, so here's a think pair share. And again, try this one on your own. I've given answers down in the lower right-hand corner. Um, but let's work through this, and maybe it'll be instructive for you to kind of watch me go through it. So just like the previous example here, we want to calculate a p-value, and we want to come to some conclusion as to whether to reject our null hypothesis or fail to reject the null hypothesis. But using this information now instead. Let me see, let me get that out of the way there. Okay, so if we look at what we're given, all right, so we're given that the null hypothesis is equal to 25. Now let's just kind of maybe riff off of that. So if the null hypothesis is equal to 25, oh, I left something out there. What I'm missing is maybe this, and you get to watch me do a little bit of uh, Microsoft Word stuff. Okay, that'll fix that. Okay, so what we were given is that the null hypothesis is that the population mean is equal to 25. So what does that mean the alternate hypothesis has to be? What is the complement of equals? It's not equal to. And just for the sake of being complete, because this is what we were given, I'm going to say that that's our original claim. Okay, now given that this is our alternate hypothesis, what does that tell us about the distribution we're dealing with or we're working with? What that tells us is that we're dealing with a two-tailed distribution. So let's go ahead and draw a two-tailed distribution to kind of get us started here. There we go. And it's going to be two-tailed. All right, nice. Okay, and since we drew this two-tailed, let's look at our other given information. So what we're given is that the significance level is equal to 0.05. Okay, that means that our confidence level is going to be 0.95. And since our distribution is two-tailed, we're going to have to take this significance level and divide it into two pieces. So the significance level divided by 2, or alpha over 2, is going to be 0.025. Right? So we're going to, let me use this, let me use a different color. Kind of want to use a different color to show the new stuff that I've calculated. Okay. There we go. So that means the area on this tail here is alpha over 2, and that's 0.025. And the area in this tail is alpha over 2, and that's 0.025 also. And we have a confidence level of 0.95 in between. Okay. So these two boundaries are defined by critical values. Now, what kind of critical values are we going to have? Well, we're going to have Z critical values. And I'm getting that from the fact that our Z test statistic, we're dealing with a Z test statistic. So because it's a Z, that's a normal distribution. So we're going to have a positive Z critical value and a negative Z critical value. And what we were given is we were given a Z test statistic, which comes from our sample data of 1.75. Okay, and that's a positive number. So ultimately, what we're going to be trying to figure out is this 1.75, is it between 0 and our positive Z critical number, or is it above? Is it above that? And, kind of why is that important? Well, that's important because over the significance level, we have this region, which is to reject the null. And between the two critical values, this is where you fail to reject the null. So by determining whether the test statistic is going to lie here or lie here, will determine whether we're going to reject or fail to reject. And the other thing we're going to want to figure out, or we're going to want to calculate, is what is the p-value that is adjacent to that test statistic. We'll calculate that as well. All right. So first, let's get our critical value. So the critical value is the boundary to the significance level divided by 2. So let's use inverse norm for that. Or let's see here, we'll do the numworks calculator first just to kind of change things up. So I'm already looking at the normal distribution. All I need to do is change the area here. Let me back up just to kind of show this from the beginning. So, you can hit the home screen, which will bring you here. Again, we want to go to the distributions app. Go down to normal, mean of 0, standard deviation of 1. Okay, and here we are. So area to the right, right? So this is an area to the right, which is fine. And we want 0.025. And when I hit enter, it's going to give us the critical value. I'm going to put 1.96. Okay. So let me go back. So we have a critical value of 1.96. Now, let me show how to get that critical value here with the Texas Instruments calculator. So we want to go to inverse norm. Okay, we have an area of 0.025 with a mean of 0, standard deviation of 1. And I want the area to the right to be that. So now I will hit, come on, paste. And I get 1.96, same value that I just got. All right, so all by itself, if we compare this value of 1.96 with our test statistic of 1.75, I think you can see that between these two, comparing apples to apples, 1.75 is going to be less than 1.96. So it'll be some number here between 0 and 1.96. And that in turn is going to indicate that we're going to fail to reject the null in this case. So this is one way of coming to that determination. But what we want to also do is to learn how to calculate the p-value. And the p-value is the area adjacent to the test statistic. So this is the p-value. Now what you'll notice is that this red area that I just shaded is the p-value, and that is greater than the significance level divided by 2, which I shaded in green. So remember the rule is that if p is smaller then reject the null. And the p-value is clearly not smaller. It is a larger area. So again, the comparing it oranges to oranges, right? P-value to significance level divided by 2, that's also going to indicate that we're going to fail to reject. But let's go ahead and calculate this p-value. Okay. So let's do this with the numerics calculator first. So I'm going to use the area to the right, and the test statistic, I was just looking at it, is 1.75. So we want the area to the right of 1.75. So that gives us an area of 0.04. Come back over here. That's going to be 0.04. And if you compare this area to the significance level divided by 2, you can clearly see that the p-value is larger. So because the p-value is larger, we're not going to reject the null, we're going to fail to reject the null. And I may not have shown how to get that p-value with the Texas Instruments last time. So let me make sure I do it this time. So we're going to use normal CDF now, because we're going to use a value to convert to calculate an area. So the lower bound is 1.75. The upper bound is infinity, which is going to be E99. Okay, we have a mean of 0 and a standard deviation of 1. So I'll go down and hit paste, hit enter, and we get an area of 0.04. All right. So the two things we needed to calculate is we needed to calculate the p-value. And so the p-value is 0.04. And the other thing was to come to a conclusion, and that is that we're going to fail to reject the null hypothesis. Okay. So this concludes that example. Let me know if you have any questions.